Hello everyone, hope you're good. Today I'm going to talk about logistic regression in SPSS. Logistic regression is a method used in classification problems when you need to distinguish one class from another. The simplest one is binary classification. The question that leads to this method can be answered with either yes or no. And so we have two classes, a positive class and a negative class. For example, we have obtained information on various users from the social media sites, and a car company has recently launched a new car, and the company wanted to check how many users from the dataset wants to purchase the car. So we have users' ID, their gender, their age, their estimated salary, and if they purchased the car or not. Which we determine that by nominating 0, not buying the car, and 1, buying the car. So here purchased is the dependent variable, and salary, age, and gender are the independent variables. So let's check the assumptions quickly before conducting the analysis. Assumption number 1 is that your dependent variable should be measured on a dichotomous scale, those which include two groups like gender, presence of disease, and so on. So our dependent variable for this example is purchased with two groups of yes and no, so it's met. And assumption number 2 is that you have one or more independent variables which can be either continuous, interval or ratio, or categorical, ordinal, or nominal. So salary and age are continuous and gender is nominal. And move on to the third assumption, which requires having independency of observations, and the dependent variable should have mutually exclusive categories. And there should be no outliers, and also there needs to be multicollinearity, meaning that your predictive variables are not too strongly related to each other. And to check that, we need to go to the path of linear regression procedure. So go to Analyze, Regression, Linear, and now put your dependent variable or purchased into dependent box, and put gender, age, and estimated salary into dependent box. Into independent box. And then click Statistics and check Collinearity Diagnostics, and then continue, and then OK. So now scroll down to coefficients table, and we check the tolerance column of this table. And what we see here is that all the values are above 0.1, approximately 0.8, 0.83, and 0.75. So it indicates that the null hypothesis of multicollinearity has been met. So we're good to go. And also for outlier assumption, we can check that along the running logistic regression. And now to do the binary logistic regression, go to Analyze, Regression, Binary Logistic, and transfer purchased into dependent box, and age and salary and gender into covariates box. Here method named inter means that all the predictive variables will be checked at the same time. So then click on categorical button, and now transfer gender over here, and then in the change contrast box, change the reference category as first. This is more useful when you have different value and you want to the lowest value to be the reference group. Like in our case, 1 is indicating male and 2 is allocated to female. So the lowest is treated as a reference group here, which is male. Click on continue. Then click on options. Check classification plots, Hosmer-Lemay show goodness of fit, and case-wise listing of residuals, confidence interval, and then continue and then OK. So scroll down to block 0 and classification table. This result was conducted before having predictive variables, and spss has predicted that all the social media users would not buy the new brand car, and 100% are in no purchased row. And now scroll down to block 1 results and look at the classification table for this step 2. In this step, the model has incorporated the predictive variables, and you can see the number of people has bought the car, actually are aiming to buy the car. And next, go to omnibus tests of model coefficients table. And we have p-value with the amount of 0, which is lower than 0.05. So it means that the model with the predicted variables was significantly better than the model without the predicted variables. So, and the next table is model summary, which shows the variation within the outcome variable. And we have 2 methods of estimating the amount of variance predicted by the model. And it varies from 71% to 100%. So, and the next table is the Hosmer and Lemay show test table. And it's checking the goodness of fit, which p-value here is greater than 0.05. So it indicates that the model is a good fit of the data. And then go down to the variables in the equation table. First, look at the gender row. It is negatively related to purchasing the car. And if you can remember, we defined 1 as male and 2 as female. And we coded purchasing the car 1 and not purchasing the car as 0. So this negative value here means that there is a decrease in the likelihood of purchasing the car if the individual is female. But the p-value of gender is 0.9 and greater than 0.05. So it means that gender doesn't really make a significant contribution to the model. So if you check the p-value for other variables, you can see that the same conclusion applies. So none of them make a significant contribution to the model, surprisingly. And then go to the case-wise list box. So you can see here that nothing has been detected because no outliers were found. And thank you so much for watching this video. I hope you liked it, and if you did, please like it and subscribe to my channel. And I'll see you in the next video.